In this video, we're going to find the area of a parallelogram determined by two vectors. So, we're told that the points 1, 2, 3, 1, 3, 6, 3, 8, 6, and 3, 7, 3 form a parallelogram. And we're asked to find the area of that parallelogram. So the first thing we're going to do is find two vectors that will determine that parallelogram. So the easiest way to do that, I think, is just pick one of the points. I chose the point K and go from K to L and K to N. Notice if I tried to go from K to M, I wouldn't get a parallelogram. I get this triangle idea. So I need to go to K to L and K to N to get the parallelogram. So we'll do the L minus the K in terms of the components. So the vector from K to L is 0, 1, 3. The vector from K to N is 2, 5, 0. Now, we know that the magnitude of the cross product will give us the area of the parallelogram determined by those two vectors. So we'll take the vector KL and cross it with the vector KN. So we'll use ijk as our first row, the components of KL as our second row, the components of Kn as our third row, and then remember we can use expansion by minors to get our vector. So eliminate the row and the column with the I in it. 1, 3, 5, 0 is the determinant I need to take. We'll multiply that by the I. Remember, remove the row and column with J in it. 0, 3, 2, 0 is the determinant remaining that we'll multiply by J. We have to take a negative of that one. And then same thing with our K, remove the row and the column. We're left with the determinant 0, 1, 2, 5. Multiply that by the K. 0 minus 15 gives us a negative 15i. 0 minus 6, minus a minus 6, so we get a plus 6j. 0 minus 2 gives us a negative 2k. So remember, when we do the 2 by 2 determinants, we do the main diagonal, upper left to lower right, and then subtract that product, and then subtract off the product of our off diagonal, the lower left to upper right. Now we just need to make the magnitude of this vector we just found. So that's the square root of negative 15 squared plus 6 squared plus negative 2 squared, or square root of 265.